In this video, I'm going to talk a little bit about something called the minor of a matrix and the cofactor of a matrix. I want to start, though, by going backwards just a little bit. In the previous video, we said that, or in the previous section, we said that the determinant of a matrix was defined, in this case, as the first row, first column value times the determinant of the sort of small, relatively small sub matrix of the rows that didn't get crossed out. So if I were going to cross out the first row and the first column, right, the rows that didn't get crossed out form a sub matrix. And if we take the determinant of that matrix, we get A22 times A33 minus A23 times A32. And then we said we were going to subtract the next term. We have A12 is our kind of coefficient, and then we would add the last term, A13 times that determinant. So let me just fill these in real quick. For A12, the determinant, I'm going to have A21, A33 minus A23, A31. And for the A13 determinant, I have A21, A32 minus A22 times, oh, I stopped looking at the screen for a second and I've lost track of where I am. So let's see, I have that A13 is my leading factor, and so it's this submatrix here I'm working with. So A21, A32 minus A22 times A31, A31. And at the time, I just said, please take my word for it, that your first term is positive, your second term is negative, and your third term is positive. What we're going to be talking about in this video is something called the cofactor of a matrix entry. And to do that, we need to talk about something called the minor of a matrix entry. So let's get some vocabulary down and we'll go from there. In this example, the one that's already on the screen, I omitted the first row and the first column. So that's a 1, 1, first row, first column. And what I'm left with then, all the entries that did not get crossed out, the determinant of that is called the minor of the first row, first column entry. So I'm looking at the minor of this entry here, the minor of A11 is M11, and that's just equal to the determinant of, I'm going to call it matrix sub A. That's not really real notation, but hopefully it'll help you see it. I've got it highlighted already here in kind of a gray. This is the sub matrix, what I'm calling sub A, right? That matrix there has a determinant, and once we figure out what it is, that determinant is what we call the minor for this entry right here. So let's do an example. Let's take the matrix B, we'll call it B, and I'll just make one up here. That's kind of what I've been doing. And we'll go with 1, -1, 2, 0, 2, 1, -2, 1, -1. And let's find the minor of entry 1, 1. Okay, so I'm looking for the minor of this entry, which means, to all intents and purposes, cross out the row and the column to which that entry belongs, and take the determinant of this sub-matrix here. The minor of entry 1, 1 is equal to 2 times -1 minus 1 times 1, which is -3. So M11, minor of entry 1, of row 1, column 1, that entry, the minor of that entry is -3. Now, when we found the determinant of a 3 by 3 matrix, we used the minor of the first column, first row entry, which was this determinant, the minor of the first row, second column entry, which is the determinant of these 4 entries, and the minor of the first row, third column entry, which was the determinant of these 4 entries. But we're not restricted to that. We could, for example, find for matrix B, minor, let's go with 3, 2. That means find the minor of the entry that is in row 3, column 2. So we're looking for the minor of this entry, and that's equal to the determinant of, let me use a different color and I'll highlight here. The values that are left over when I I used highlighter in this case, right? So looking at my highlighter, my gray highlighter down here, I crossed out row 3 and column 2, and the entries that are left are these 2 and these 2. So I want the determinant of this submatrix, and that's going to be 1 times 1 minus 2 times 0. So I can find the minor of any entry in a 3 by 3 matrix, or in fact in any square matrix, but we're going to stick with 3 by 3 for now, just because I need to make a point before we go on. So this is what's called the minor of the entry of a matrix. That's the word minor, and that's what that is. It's a determinant of a submatrix. The cofactor of the entry of a matrix is that same number, but it's either positive or negative depending on where it sits, and that's really all that is. The cofactor is found by applying a little formula to once you've found the number. Let's see, let's use the minor of, for matrix B, minor 3, 2, and we're going to say that the cofactor, I'll put it in a box down here, the cofactor 3, 2 is equal to the minor 3, 2 plus or minus a sign. So it's either going to be positive or it's negative. And the way you figure out whether it's positive or negative is that you multiply that minor value by negative 1 to a power. And the power that we're going to use is the sum of the values in the subscript here. This 3, 2, that's 3 plus 2. And the reason for that is that this is in row 3, column 2. And it turns out that these cofactor, the signs of the cofactors just alternate in a pattern. And I'll get to that in the next video. I actually would prefer to show you that they alternate and then show you the formula for finding them, but your textbook presents them in this order. So I'm just going to go ahead and stick with that. So we figure out whether or not the sign of the cofactor is positive or negative by using this little formula. We found that our minor was 1. Oops, I got the wrong color here. Let's pick a different color. Okay, and then I have to decide whether it's going to be a positive or a negative that goes in front of it here. And I'm going to do that by adding together 3 plus 2, which gives me 5. And then when I raise negative 1 to the power of 5, I get negative 1. So my cofactor value is negative. Let's move to a new screen, and I'll do another couple of examples for some cofactors for entries in different positions. Okay, here's a new matrix I'm calling C, and I want to find the cofactor of, let's say, entry 2, 1, the cofactor of entry 3, 2, and the cofactor of entry 2, 3. All right, so the cofactor of entry 2, 1 is going to be the determinant of the values that get left out when I cross out row 2, column 1. So I think I'll do that in highlighter this time. Row 2, column 1 leaves me with 2, 0, and 1, 0. And if I take the determinant of that, notice I've used the vertical value bars because the cofactor is, actually I'm going to put a plus or minus here. The cofactor is either positive or negative, the determinant of the values that get left out or that are still remaining, you might say, when you cross out row 2, column 1. Row 2, column 1. All right, and that those values are 2, 0, 1, 0. So if I take the determinant of that, I get 2 times 0 minus 1 times 0, which is 0. So in this case, I don't actually have to do my computation for whether or not the sign of that entry or the sign of that cofactor is positive or negative, because 0 is the only number that has no sign. Exactly 0 is the place on the number line that divides the positive numbers from the negative numbers. So 0 itself has no sign. Okay, so that's that one. That was easy. Let's do row 3, column 2. I'll use a different color highlighter. I have row 3, column 2. So now notice where the values get crossed out. More importantly, notice where the values that are not crossed out by the green highlighter, and that is 1, -1, and 0, -2. The determinant of that submatrix is going to be 1 times -2 minus 0. So it's either positive or negative, -2. Positive or -2, I could say that this is equal to negative or positive, +2. That would be another way to write that, but it's really not, strictly speaking, necessary. So I'll get rid of that. But now we have to figure out what that sign is. And the way to do that is I'm going to go off to the side here, and I'm going to say that I'm going to take -1, and I'm going to raise it to the power 3 plus 2. You know, I'm going to change this one because I'm ending up with all odd values, and that's not what I want. But for this one here, I'm going to add the values of 3 and 2. So I'll put that up here, 3 plus 2, that's 5. And -1 to the 5 to the 5th power is -1. Right? So my value here is going to be negative, use a highlighter, negative -2. So my cofactor here is 2. Okay, and I said I was going to change this last one, and I'm also going to give myself just a little bit more room. Let's look at the cofactor of row 2, column 2. And that means, in order to find that, I need to cross out row 2 and column 2. I'm using pink this time, and anything that's not crossed out by pink is a 1, a -2, a 0, and a 0. That's going to be 0 also, which didn't really help my cause. Let's try one more. Let's do the cofactor of 3, 3. Entry row 3, column 3. I'll use blue. My highlighter is blue this time. Row 3, column 3. I crossed out the column first there. That's okay. Row 3, column 3. The cofactor of that entry is going to be anything that wasn't crossed out by blue. Let's see, that's 1, -1, 2, 0. Find that determinant. And we get 1 times 0, which is 0, minus 2 times -1, which is -2. So I get 0 minus -2, or 2. Off to the side, I'm going to say that's the sign is determined by the sum of 3 and 3. And that's 6. And -1 to the 6th power is +1. So in this case, I'm going to take the positive sign for my cofactor. Now, earlier in this video on a previous screen, I said I was going to talk about the signs pattern in the next video, but I think I'm just going to go ahead and do it here. If you think about the fact that row 1, column 1 is going to have a cofactor whose sign is decided by adding together let's write that out. Cofactor 1, 1 is going to have a sign that is -1 to the power of 1 plus 1 times the minor 1, 1. Cofactor 1, 2, -1 to the 1 plus 2 times the minor of 1, 2, and so on. I can just look at this entry and say that's in row 1, column 1. And so its sign is going to be -1 to the 1 plus 1. That's positive. Right? 1 plus 1 is 2. -1 squared is +1. In this entry, I'm going to have -1, a sign determined by -1 to the power of, this is row 1, column 2, so 1 plus 2 is 3. Well, -1 to the third power is -1. It's negative, so that's going to be negative. In my next one, I'm going to have row 1, column 3. 1 plus 3 is 4. -1 to the fourth power is negative. Row 2, column 1 is 2 plus 1, which is 3. -1 to the third power is negative. Row 2, column 2, 2 plus 2 is 4. -1 to the fourth power is positive. Row 2, column 3, 2 plus 3 is 5. -1 to the fifth power is negative. Row 3, column 1, 3 plus 1 is 4. -1 to the fourth power is positive, and so on, and the pattern just continues alternating like this. Now, our matrices are always square, and sometimes you'll see this in a matrix of its own. I actually see matrix bars around it here. For a 3 by 3 matrix, that's what that would look like. But in fact, the pattern continues regardless of the size of the matrix. So I could add a negative and then a positive and then a negative and so on. That would be a positive and a negative and a positive and so on. And the pattern just continues. But these need to be square matrices. So I also need to include the fact that the pattern continues in this direction as well. See, positive and a negative, negative and a positive. This is highly unnecessary. The point is that the matrix continues, that the array of signs continues regardless of the dimensions of the matrix, as long as it's a square matrix. Okay, I'll just put a dot, dot, dot here as well, but it's interesting to note that no matter what the dimensions of your matrix are, this value is always going to be positive. And the reason for that is we're working with square matrices. So you're either going to have a 1 by 1 or a 2 by 2 or a 3 by 3 or a 4 by 4. And if you have an n by n matrix, regardless of whether n itself is odd or even, n plus n is 2 times n, and that's always going to be an even number. When you raise -1 to an even power, you get a positive number. So that value is always going to be positive. Your textbook doesn't indicate that, but that will always be the case. Now, the other thing I'd like to point out here is that the value itself is not always positive. We saw that in our example up here, where we found the cofactor of entry 3, 2 by taking the determinant of these 4 values, and we found that that determinant was the number -2, but because of where we were, that was row 3, column 2, row 3, column 2, so we're in this position here, that's row 3, column 2, that's this position here, so our cofactor needed to be negative whatever the determinant was. Sorry, negative whatever the minor was. And that was a negative value. So we ended up taking the negative of this -2, which gave us a +2. So the value is not necessarily negative, right? The value that goes in this, the value that you end up with, I guess, is not necessarily negative just because of the position it comes from in the original matrix. But its sign is determined by, in this case, being the opposite of what our minor was. So we have done what we set out to do in this video, which was to talk about the minor, how to find it, and the cofactor and how to find it, as well as how to determine the sign of the cofactor in a couple of different ways. One is by using this little formula that the sign, I'll call it the sign of a cofactor, is equal to -1 times I plus j, where the entry has come from the ith row, jth column. So that I plus j goes there. So we found the sign of our cofactors by using this formula. And we also found the sign of our cofactors by using this sort of array, this grid of signs, this alternating grid of signs. No matter the dimension of your of your original matrix, the first row, first column will always have a positive sign. And because they alternate, even whether this ends in a negative or a positive, the next one will always end in start with a negative, right? So they alternate in this direction as well. All right, so we've discussed how to find a minor and how to find a cofactor, a couple of different ways.